Hello everyone, welcome to today's class. We'll be starting with a new topic known as straight line. Okay, this topic, I'll say again, it will be correlated with few other chapters also. So cover this as a basic and then we'll be using it as an application in other topics. It will come in your differentiation, it will come in your integration applications. Okay, all right. Let's go through the basics of coordinate first of all, because we'll be dealing with straight lines, so everything is in the Cartesian plane. Okay, so suppose you have 2 points x1 y1 x2 y2 and you need to calculate what is the distance between these two. Okay, so the distance is given by this formula, that is square root of x2 minus x1 whole square y2 minus y1 whole square. Like for this example, if we consider this as my x1 y1, this as my x2 y2. Okay, so now just apply the formula, x2 minus x1, so 3 minus 6 whole square plus 0 minus minus 4, this is minus 4. Okay, so 0 minus minus 4 whole square. Okay, in case it is not visible, I've highlighted it now. x2 minus x1 y2 minus y1 whole square. So 4 square 3 square 9, you'll get 9 plus 16 25, which is square root of the square root is 5. So 5 is the distance. Same way, suppose you have 2 points x1 y1 x2 y2 and they are being divided by some point in some particular ratio. Okay, let me show you with the help of this example as such. So you have 2 points, one is A, one is B. The coordinate for this is 1 comma minus 3, that's your x1 y1. The coordinate for B is minus 3 comma 9. Okay, so that's x2 y2. Okay, and let's join them. Okay. Suppose there is another point which divides them in some particular ratio, and the ratio is given as like 1:3, and you need to find the coordinate of this xy. Okay, x comma y. So the x coordinate is given by this formula. Okay, mx2 plus nx1. Okay, this is your m, this is your n. Okay, m ratio n. So basically what you do, you multiply this ratio with this coordinate and this ratio with this coordinate. So I don't tend to remember this formula like this. I have the tendency to draw it and then see accordingly that 1 will be multiplied with minus 3. Okay, like this is happening. 3 will be multiplied with x coordinate 1 upon add the ratios. Denominator is by adding the ratio. Okay, if you are comfortable with this notation directly, you can use that also. Okay, mx2 plus nx1 upon m plus n. Similarly for y coordinate, my2 plus ny1 upon m plus n. Okay, same thing here is done. 1 multiplied by 9, 3 multiplied by minus 3. Okay, and then addition of ratio, that's 3 plus 1. You can solve, you will get the x coordinate and y coordinate of this point. In this case it is, in this example it is coming 0 comma 0. So 0 comma 0 is the point which divides this line segment in 1:3. Okay, something basic of coordinate. Similarly, if you need midpoint of 2 points, let's say this is x1 y1, this is x2 y2, and we will be needing a midpoint as such for this chapter. In between we will require midpoint. In order to get the midpoint x comma y, that x will be given by this x1 plus x2 by 2, means in order to get the midpoint, add the x coordinate, then divide by 2. Similarly for y coordinate, add the y coordinate, y1 plus y2 divided by 2. Okay. Then area of triangle, it's a lengthy formula as such. I'll not recommend you to learn this anyway, because see, we will be dealing with what you call it, determinants. So in determinants, we'll again talk about this area of triangle using determinants. So I think it is better to use that rather than this lengthy formula, so don't learn this. Okay. All right, now let's start with some basics. First of all, we'll talk about any general equation of line. How will it look like? So any general equation of line will look like ax plus by plus c equals to 0. Okay, a, b, c will be some numbers. Now if we talk about line, let's draw xy axis first of all. Okay. Let's take any line. Okay. So let's say this is the line. Whenever a line is in this xy plane, okay, y-axis, x-axis, somehow this line cuts x-axis. Okay, it is possible that it may not in a particular scenario, but let's say in general a line cuts x-axis. Okay, so once again, yes, let's continue. So we were saying that anyways the line will cut somehow x-axis, or it may not in a particular scenario also, but in general we'll say it cuts x-axis. So somehow this is making some angle with this x-axis. Okay, let's call this as theta. Now the first term that you have to study in this chapter straight line is this word known as slope of a line. Okay. Now slope of a line, first of all, it will be represented by m. Okay, and this m is tan of this theta. Remember that it will be measured always with positive x-axis. Angle will always be measured with respect to positive x-axis. Okay, and whatever that angle is, tan of that angle is known as slope, is this tan theta. There is another way to calculate slope. Okay, suppose you have 2 points on this line, let's say here and here. Okay, x1 y1, x2 y2. So another way to calculate the slope is y2 minus y1 upon x2 minus x1. So if 2 points lie on a line and we know the coordinates, we can calculate the slope using this formula also. Okay, slope is tan theta is equal to y2 minus y1. Okay, so using anything we can calculate slope for time being. This is the formula. Okay, all right, but remember that if we are taking in terms of theta, then angle has to be measured with positive x-axis. This was covered in trig also. Okay, let's see a few examples. Yeah. Okay, so just some basics. A part is saying find the slope of a line passing through these coordinates. Okay. Negative is not too much highlighted, so I'm highlighting this 3 comma minus 2, 1 comma minus 1 comma 4. Okay, so x1 y1, x2 y2. First part, slope is y2 minus y1, so 4 minus minus 2 upon minus 1 minus 3, so that give you 6 by minus 4, that's minus 3 by 2. Slope of first line is negative. Okay, second thing, m, same thing, y2 minus y1, so 7 minus 3, sorry, not 7 minus 3, y coordinate first, na? So minus 2 minus of minus 2 upon 7 minus 3. Okay, y2 minus y1 upon x2 minus x1. This becomes 0 by 4, that's 0. Okay, third part, passing through 3 comma minus 2 and 3 comma 4. So m is 4 minus minus 2 upon 3 minus 3, that's 6 by 0, that's infinite. Okay, we'll not say not defined, we'll say infinite. Okay, so far from these three parts, what you can conclude? You can conclude that m can be positive, m can be negative, or m can be 0 also, or m can be infinite also. So every single value of n will represent something. We'll talk about that. Okay. Right now there are 4 possibilities for m: positive, negative, 0 and infinite. Okay. All right. In order to understand what's really happening, let's analyze this. Then of course we have to learn the conclusion. I can give you the conclusions directly also, but let's analyze x, y axis. This is just for one time. Okay, you have to understand this for one time, not every time we'll be doing this. The coordinates were 3, -2, so I'm approximately plotting them. 1, 2, 3, -2, 1, 2 here. Okay, and -1, 4, -1 will be here. 1, 2, 3. Okay, -1, -2, -3. 1, 2, 3. -1, -2, 1, 2. Okay, so 3, -1 is plotted. 3, -2. Oh, -1 I have plotted. -2. Okay, yeah. Then -1, 4. -1, 4. So 4 will be up here. -1, 4. If we join this, you get line like this. Okay, that's the first A part. Similarly, for the second part, 3, -2 and 7, -2. 3, -2 I have done. 7, -2. 4, 5, 6, 7. 7, -2 will be again here. Okay. If I join them, that's my B part. Okay. Let me change the colors. Okay, this is the first line, so let's say, okay, third one is 3, -2 and 3, 4. 3, -2 I have drawn. 3, 4. 3, 4. 3, 4 will be here. So if I join it, it will be like this. Okay. 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 So A part, B part, C part. Okay. If you see the B part, this is the line, red one. So m was 0. m0 will imply what now? If m is 0, that means I can conclude that it will be a line parallel to x-axis. Okay, that's my x-axis now. This is y-axis. Similarly, third line, in which m is infinity, implies that it is a line parallel to y-axis. Okay, and if you get the first part, this was the line. Look at the angle. It is obtuse angle, the theta. So we get slope as negative. So slope is negative. That means what we can say, that angle is, or we say theta is more than 90 degree. Okay. So I think pretty much you can understand, if theta is positive, theta will be less than 90 degree. Okay, that's the overall conclusion that I was trying to make out of this. I could have directly given you also the same thing, but I think this was interesting, rather than just directly stating that m equal to 0 is a line parallel to x-axis, m equal to infinite is a line parallel to y-axis. Okay, and see tan theta, if theta is less than 90 degree first quadrant tan is positive. You can understand from there also. Okay, similarly negative, theta is more than 90 degree second quadrant m is negative. Okay, So this table you should remember. Okay, m equal to positive, negative, what do they represent, and 0, infinite, what do they represent. Fourth point, let's do that. I haven't discussed the fourth one. Making inclination 60 degree with positive x-axis. Okay, 60 degree with positive direction of x-axis. Okay, they should mention the clockwise, anti-clockwise too. So for the last part, I again have to redraw it. Is saying the fourth part, a line making inclination of 60 degree with positive x-axis. Let's draw it. So it is, a line can be like this, although it doesn't matter whether it is passing through origin or not, but for simplicity I have drawn like this because the question is not saying anything. So I'm making angle with positive x-axis here. This is 60 degree. This is our actual theta. So we can directly say m is tan theta or tan 60, that's √3. Okay. You might think that what was the overall point to draw it. You'll see in one of the question that will come later that sometimes they will give you angle with negative x-axis also, or positive y-axis or negative y-axis also. In that scenario, always draw the line, then judge your theta always with positive x-axis and then calculate. Okay. Variations part I'll cover when the question will come. Okay. All right. Now, next topic is condition for parallel and perpendicular lines. Okay, two lines can be of course parallel. Suppose like this. This is L1. This is, there are two lines. Okay, L1, L2. And we have to talk about parallel line. What is the condition of parallel line? So condition of parallel line is this line will have some slope m1, this line will have some slope m2. The condition for parallel line is m1 is equal to m2. Okay. Similarly, condition of perpendicular lines. So let's draw it. Let's say these are the two lines which were perpendicular, slope m1, slope m2. Okay, so condition of perpendicular lines is m1 m2 equal to -1. Okay, the product of the slope should be -1. Okay. Alright, we'll use that later. Okay. Let's cover the next topic, angle between two lines. So suppose two lines can be at any angle. Let's say this is the scenario. Some angle between them, we have to find that. Let's say this line has slope m1, let's say this line has slope m2. Now for that, the angle between them, I'll not say tan theta because otherwise it will confuse you, that because I told you that slope is also tan theta and here I am also using theta, so I will call this angle as alpha so that you don't get confused at all. Okay, so angle between two lines will resemble it by alpha. It can be anything of course, theta also, but I am not calling it theta. So tan alpha is equal to m1 minus m2 upon 1 plus m1 m2, mod of it. What does mod do? Make things positive. Modulus. Okay, we'll have to study modulus a lot in a lot of chapters anyway. All right, let's see the use. Finally, I've given you a lot of conditions now. Let's see how to use them. Okay. Somehow the first example itself is slightly typical. He's saying there are two lines and the angle between them he has already given to you. He's saying slope of one line is 1 by 2. That's your m1, let's say. He's saying find the slope of the other line. He's asking for m2. Okay. So alpha is, this is our alpha, na? Alpha is pi by 4. So let's use the formula. Formula is tan alpha is equal to formula m1 minus m2 upon m1 plus, upon 1 plus m1 m2. Now tan alpha means tan pi by 4, which is 1, we know, and there is a mod present. So modulus of m1 is 1 by 2 minus m2 upon 1 plus 1 by 2 m2. This is what we have to solve. We have to solve for m2. Okay. Tan pi by 4 is 1. Okay. So 1 is equal to modulus of 1 by 2 minus m2, 1 plus m1 m2. Modulus close. Look at this. Tell me if mod x is equal to 3, what is the value of x? Try to think. Pause the video, think about it, then play the video. See, if mod x is equal to 3, x could have been 3 or x could have been minus 3 also. We don't know. The point is, if the variable is inside the mod, we cannot be sure whether it was positive or negative, because effective result will be positive. So it could have been 3 also, because mod of 3 is 3. That's correct. And even if it was minus 3, mod of minus 3 is also 3. So we cannot be sure. It can be 3 or minus 3. Same thing here. Since your m2 is unknown, okay, 1 by 2. Since your m2 is unknown, you don't know, that modulus could have been 1, means the value after solving it could have been 1 also, could have been minus 1 also. So the idea is, whenever you get mod x or mod of some variable is equal to some constant, open it with positive and negative. Okay, so x could have been 3 or minus 3. So whenever you get like this, mod x equal to 3, write down x is equal to plus minus 3. Okay, same thing here also. So I'll say 1 by 2 minus m2 upon 1 plus 1 by 2 m2 is plus minus 1. Okay, I hope this step is clear, because this is very crucial, how to deal with mod, and usually this is where students will make mistake. That means we have to solve it both for 1 also and minus 1, means you'll get 2 values of m2. Yes, 2 answers. Okay, so let's solve for positive one first. So 1 is equal to 1 by 2 minus m2 upon 1 plus 1 by 2 m2, and the other part that we have to solve is for minus 1. Minus 1 is equal to 1 by 2 minus m2, 1 plus 1 by 2 m2. Cross multiply and solve. I think we have taken a lot of time now. So 1 plus 1 by 2 m2 is equal to 1 by 2 minus m2. Here minus 1 minus 1 by 2 m2 minus, not minus, is equal to 1 by 2 minus m2. More space. It's a lengthy question, somehow slightly lengthy, I'll say, but the concept is very important regarding this mod. So 1 minus 1 by 2, you'll get 1 by 2. Take this on the other side, you'll get minus 3 by 2 m2. 2 cancels, you'll get m2 as minus 1 by 3. Okay. M2 could have been minus 1 by 3. Same thing here also. Minus 3 by 2 m2 is equal to, take it positive, it will become plus, not plus, minus 1 by 2. Minus 1 by 2 m2. 1 by 2, 1 by, what I've done, sorry. Minus 3 by 2 is equal to this. So 1 by 2, 2 cancels, you'll get 3. M2 as 3 also. Okay, so you are getting 2 values of M2. M2 as 3 also, M2 as minus 1 by 3 also. Both values are correct. for both the values of the slope, the angle between the two lines will be pi by 4. And I'll tell you why this happens. You can actually analyze. See for yourself. Suppose this is a line, and I ask you to make a line which is at a 45 degree to it. 45 degree, pi by 4 is 45. You'll say, yeah, this line could have been at a 45 degree, and this line could also been at a 45 degree. Okay, both the angles could have been pi by 4. This could also be pi by 4, this could also be pi by 4. So for a given line L, there could be two possible lines with angle between them as pi by 4. So that's why they are getting two values of m2. This is 1 m2. Let's say this is m2 is equal to minus 1 by 3, and this is, let's say, m2 is equal to 3. I'm just hypothetically stating this. Of course, slope negative, the orientation of line will not be like this. It should be like obtuse angle. But I'm just stating this, that this is the reason why it is happening. Okay. All right. So the first example itself was slightly tricky, but I hope you get the idea. So remember that whenever mod x is equal to 3, or whenever you have a variable inside a mod, you open the mod with positive as well as negative. Okay, that's the overall thing that you need to learn from this. Rest formula application is not typical. Cross multiply and solving it, again, not typical. Okay, let's take one more example. He's saying line passing through this is perpendicular to the line passing through this. Finally, yes. So 2 points, line is passing through this, it will have some slope, let's say m1. Another 2 points, line will pass through this, let's say slope m2. And if they are perpendicular, can I directly say m1, m2 should be minus 1? Using this, we can easily find out x. Let's derive, let's find. First slope, 8 minus 6 upon 4 minus minus 2. Okay, so that's 6. So I'll write it 4 minus minus 2. 4 minus minus 2. Into the other slope is 24 minus 12 upon x minus 8. Okay, multiply them, should get minus 1. So 8 minus 6, 2 upon 6 into this, you will get 12 upon x minus 8 is equal to minus 1. Okay, so you will get 4 upon x minus 8 equal to minus 1. Solve it further. X minus 8 equal to minus 4, x is equal to 4. Okay, how you solve it, again, it's depending on you. I have solved it in my way. The point is, you should be able to identify the approach of the question. Say the moment you see any question, look at the main conditions, perpendicular. The moment you see perpendicular, write down this condition. Then think, how can I get the slope m1 using 2 points? Using 2 points. Okay. All right. Let's look at the last point for this, and then we'll be dealing with the questions. Okay. A lot of questions are there. Collinearity of 3 points means the 3 points should lie on a straight line. Okay. So let's say there are 3 points. 1, 2, 3. x1 by 1. Let's say x2 by 2. x3 by 3. Let's say name the points A, B, C. If I have to prove that they are collinear, see, earlier there were a longer method which was like try to find the area of the triangle using these 3 points, and there should become 0. So you'll say since area of triangle is 0, you'll say the points are collinear. Well, very lengthy approach. There is an easier approach. The idea is for slope. This is a line. Each line has unique slope. What is the meaning of unique? A single value. Okay, each line has a unique slope. That means if I calculate slope using AB, MAB means using A and B point, you calculate the slope. That should be equal to slope using BC. That should be equal to slope using AC. I think in order to prove it, you use any two. I've given you three expressions now here. MAB is equal to MBC is equal to MAC. You just prove anything like this, like prove just like MAB is equal to MBC, slope of AB is slope of BC. You'll say, you can justify like, yes, the points are collinear because the slopes are same, so they must lie on the same line. Or use these two, or use last two, any two, use any two. Okay, if you want you can use three also, like, but the question will not be asking you to, of course, prove points are collinear. He'll give you some variable and then he'll ask you to find the value of x or y accordingly, so that the points are collinear. Okay, anyway, I've given you the basic condition. Let's put it in a box. All right, use any two. Okay, we are done with this. Now let's solve few questions. Theory is done. Okay, the first question. Find the slope of a line which passes through origin and the midpoint of line sign joining these two segments. So somehow midpoint is involved. Okay, so these are the 2 points. We have to calculate the midpoint. How do we calculate midpoint? This is negative. Okay, so just how do we get the midpoint? Add the x coordinate, divide by 2. So 0 plus 8 divided by 2. Add the y coordinate, minus 4 plus 0 divided by 2. That's 4 comma minus 2. Now we have the point. This is the midpoint, and we have the origin 0 comma 0. Okay, so 2 points are there, 0 comma 0, and the midpoint is 4 comma minus 2. We need to calculate the slope of this. How can we calculate? M is equal to y2 minus y1 upon x2 minus x1. All we need is 2 coordinates. So minus 2 upon minus 2 minus 0 minus 2, and 4 minus 0 is 4. So minus 1 by 2 is the slope. Okay, simple enough. I'm starting with the easy questions now, so you get comfortable with slope. Okay, now comes the question that I was talking about, the variation part of it. Let's create some more space. Is saying find the slope of a line which makes 30 degree with positive x-axis, sorry, with positive direction of y-axis. So instead of x-axis, first of all they have said y-axis, measured anti-clockwise. So for this, always draw x-axis, y-axis. Okay, and I'll cover the variations of it. Now, in order to judge how your line will be, it is making 30 degree with positive y-axis. So this is your y-axis, x-axis. From this part, it is making 30 degree. But point is 30 degree can be here also. 30 degree can be here also. Okay. So he is saying anti-clockwise. So anti-clockwise means this one he is talking about. So the line will be like this. Okay. Now this angle he is saying 30 degree. Now once we can figure out the orientation of line, okay, he has not stated the line is passing through origin, but I have considered it because it won't make any difference. Now we know in order to get slope from angle we need tan theta, but the problem is theta is always measured with respect to positive x-axis. So what is this angle? This is up till y-axis is 90 plus 30, that's 120 degree. So that is tan 120 degree. That's what is tan 120? 180 minus 60. Okay, so that is second quadrant, tan is negative, so minus tan 60, that's minus root 3. Okay, this is done. Now comes the variation part. Second part, I am adding it. What if it was the same question with one word changed. Instead of clockwise you have instead of anti-clockwise you have clockwise. So for clockwise, same everything, it is still measured with y-axis na, so it will be like this. This is the second part. Now this time this angle is 30, but we need angle always with positive x-axis. So how much this angle will be? This will be 90 minus 30, because y-axis is 90 na, so 90 minus 30, that is 60 degree. Once you figure out that the angle with x-axis is 60 degree, you can say m is equal to tan of 60, which is root 3. Okay, let's do one more part, third one. Same question with one variation. Instead of positive y, you are measuring it with negative y-axis. So this time the angle is measured with negative y-axis. So this means this is the negative y-axis, this one. So you are measuring it in anti-clockwise. So anti-clockwise moves like this. Okay. So this angle is 30 degree. Okay. So you have still, this is the line, but this angle this time is 30. Okay. This is 30, so this is also 30. I think you'll still get the same answer, because this is 30 degree angle. That means this angle is also 30, vertically opposite, and now it becomes the same question somehow. You still need to measure it with positive x-axis na, so you'll measure it 120 degree. Okay. Suppose some students say, no, I want to measure like this. Your call, no problem. Measure it like this also, you still get the same answer. Okay. But what is the point of measuring it like this? If you already know that this is a line, so this is also the same line na, so measure it like this only. So that's 120 already, so use that. So I'm not calculating it again. M is equal to tan 120, that's minus root 3. Fourth part, same question. Negative y-axis and clockwise 30 degree. Okay, same thing. So this is the negative y-axis and you have to measure clockwise. So clockwise you will move here and this angle will be 30. Same thing now. This angle and this angle, they are vertically opposite. So that means we are talking about this same line. That means still you will measure this angle, the angle that I have written inside. That's 60. Oh, sorry, my bad. That's still 60 degree. So for this one, slope is equal to tan 60 is equal to root 3. Again, if you want, you can measure like this also, but this is the same line here also. So measure it like this, won't make any difference, because in third quadrant also tan is positive, so you'll get still the same value. Okay, so I've covered basic idea that how you can cover the variation part of it, how they can manipulate the same question in many ways for MCQs. Okay, for MCQ, for subjective also, doesn't matter. Okay, next question. Oh, collinear, the one I was talking about. I gave you the condition for collinear. 3 points are collinear. If 3 points are collinear, it means they lie on the same straight line. Okay. So x comma minus 1, 2 comma 1, 4 comma 5. If they are collinear, he's saying find x. I told you that he will be asking for variable. Some point he'll miss, some coordinate he'll ask. So same thing I'll use MAB, slope of AB is equal to slope of BC. because it's a unique line, so it have a unique slope. Means whether I use AB or whether I use BC, we'll get the same slope. So from AB, if I use y2 minus y1, so 1 minus minus 1 upon 2 minus x is equal to BC. BC is 4 minus, sorry, not 4 minus, 5 minus 1 upon 4 minus 2. You can easily calculate now. 2 upon 2 minus x is equal to, this is 4 by 2, which is 2. Okay. So you'll get 2 minus x equal to 1. So you'll get x is equal to 1. Simple enough. Okay. But you need the condition. That's the key part. How to get, you have to learn the conditions basically here. The slope of collinear lines, sorry, collinear points are same. Okay. Let's do the next one. Is saying find the angle between x-axis and the line joining this. Okay. Basically, if we draw x-axis, y-axis like this, and you have a line. Okay. The line will cut x-axis, I told you, and this angle is theta with positive x-axis, and slope is tan theta. So if I want to get the theta, I should know at least m. Let's calculate m using the other formula also, which is x1 y1 x2 y2. Using these two, we can calculate y2 minus y1 upon x2 minus x1. So minus 2 minus of minus 1. So sorry, upon 4 minus 3 is tan theta. Let's calculate. This becomes minus 2 plus 1. So minus 1 upon 1. Tan theta equal to minus 1. It is a trigonometric equation now. We have done that. We know how to calculate tan of negative angle. Okay, forget about the positive one. Tan, basic tan is 1 when angle is 45 degree, but it is negative. So for negative, we have to do in the second quadrant with 45 degree. Let's increase the size. Yeah. Okay. And now you measure it with positive x-axis. That's 135 degree. So theta is 135 degree or 3 pi by 4. If you want to go through the basic of this, revise the trigonometric equations. I've covered how to get the value of tan, sine, cos for positive as well as negative values. Okay. Again, idea. How will we calculate the angle with x-axis? First we'll calculate slope, and slope is tan theta also. Theta is angle with x-axis. Okay, let's do one more. Okay, this time he's saying the slope of a line is double the slope of the another line. So you have some slope, let's say for m1 you have slope m. So for slope m2 you have 2m, double. He is saying tangent of angle between them, means he is talking about tan alpha, and it is given as 1 by 3. So basically he is saying tan alpha, which is m1 minus m2 upon 1 plus m1 m2 mod. This is the formula. Now he is saying tan alpha is 1 by 3, m1 is m, m2 is 2m upon 1 plus m into 2m in mod. We have to solve this. So 1 by 3. Now we know what we have to do with the modulus. Minus 2m, sorry, not minus 2m, minus m. Minus m upon 1 plus 2m square. And we know what does the modulus do. The modulus will make this as, we have to solve for plus minus 1 by 3 minus m upon 1 plus 2m square. Let's take some more space. Let's solve it. Cross multiply it, and first of all we'll solve it for 1 by 3 minus m upon 1 plus 2m square. Then we'll solve it for minus 1 by 3 minus m upon 1 plus 2m square. Let's solve for this first. So you'll get 2m square plus 1 is equal to minus 3m, or 2m square plus 3m plus 1 is equal to 0. Okay, if you middle term split this, you'll get 2m plus 1 m plus 1. Okay, 2m square m 2m 3m, yeah, equal to 0. So you'll get m as minus 1 by 2 and minus 1. Okay, here if you solve this, negative negative cancels, so 2m square plus 1 is equal to 3m. So 2m square minus 3m plus 1 becomes 0. Do the middle term splitting, you'll get 2m minus 1 and m minus 1, okay, equals to 0. So you'll get m as 1 by 2 and 1. So this time you have 4 possible answers. Okay, like one of them could be in the options, but point is there are multiple answers for this. Or they can do is give you the 2-3 values accordingly, or give some combination of it. The point is, as such, there are 4 values of just m. Now what will be the slope of the other line? So 2m will be, if it is minus 1 by 2, that will be double of it, so minus 1 minus 2, and here 2m will be 1 and 2. Okay, so these are the answers plural. Okay, all right, good enough. Now so far we have done the questions in which we were dealing with numbers, but it's not always like this. Straight line can deal with arbitrary constants also, a, b, c, in terms of that. Okay, and the question can always be formulated in form of MCQ. It's not like that it should be a show that question, so we don't have to do. No, the same question can be asked like this. One of these expressions will be in the options, and they will ask you which one is correct. Like they'll write like this: h upon a plus b upon k equal to 1. One option they'll give like this, and they'll change it like few other ways they can change it. Okay, then you have to find the correct option. So let's see. First of all, let's look at the condition of the question. Is saying 3 points, this, this and this, lie on a line. That means he's talking about collinear lines that we already covered. Again, 3 points. One is h comma 0, one is a comma b, one is 0 comma k. Okay, let's call them capital A, capital B, capital C. Okay, he's saying they lie on a line, show that this. Okay, so anyway, let's generate if they lie on this, then what should be the condition? So if they lie on the same line, so MAB is equal to MBC. Okay, I can use BC also, or I told you that we can use any 2 points, so I am taking AC. It's not like that I'll not get the answer with BC, it's just that it will take slightly more time, and with AC you'll see why I'm taking it, because zeros are present in it. So MAB is B minus 0 upon A minus H, it is equal to AC. So K minus 0 upon 0 minus H. There are a lot of zeros, that's why I'm taking A and C. Okay, cross multiply, we don't have any other option, let's generate it. So B upon A minus H, it is equal to minus K by H, cross multiply. BH is equal to minus AK plus HK. Okay, he's somehow generating one point is A and B are on one side, H and K is also on one side. Let's take this one here, so at least everything is positive. So BH plus AK is equal to HK. and since the right side is 1 somehow, so we have to generate it. And you can look through the options also. If RHS is 1, that means we have to take this HK on the denominator, so BH by HK plus AK by HK is equal to 1. Okay, now H cancels, K cancels, so what do you get? B by H plus, sorry, B by not H, B by K, A by H is equal to 1, and that was your 2 proved, hence proved. Okay, so it depends on the option. By looking at the options, you can always just see what he is trying to do with the question, what he is trying to manipulate. You can always assess that. Okay, all right, this is done. All right, I think that's pretty much okay. We'll start with the next sub part of this. We'll learn, so far we have done only slope. This is everything regarding slope so far. We haven't even started with equations of line. Equation of line will start in next class. Okay, so write down all the conditions, make mini notes for all the formulas that I have given you. Okay, all right, that's all for today. See you in the next class. Good day everyone. Bye.